Well, good morning, everyone. This is Deacon from NovaStar. Today's topic, we are going to say the basic knowledge of NovaStar system. I just believe many of you are using our system now, so let me introduce something. So the first one, what is LED control system? Let's say in your project, we will use some devices and we have the cabinet and even some cables, right? All right, let's say next. So the basic unit, the LED module. One LED cabinet is composed of LED modules. The module is the smallest unit in LED cabinet. Yes, the screen is really big one, but actually it's composed by the modules. All right, for the modules, we got different types. The first one is VIP. You cannot hear or? Hello, yeah. What about now? All right, cool. If you cannot hear me, please just check the earphone or the speaker. Thank you. All right, let's move on. For the module, there got different types. We got the DIP and SMD, and also this part is back side of the module. We can see some chips, and also we can see the connectors. All right, for the second level unit, the LED cabinet, it consists of several modules arranged according to certain rules. Yes, for the LED cabinet, it's not only the modules, still we have the receiving cards. Sometimes we need the hub card. Yes, the receiving card plus hub card. And also some receiving card like MRV series, some of them, they got the hub connector on the receiving card. So we can directly use a flat cable to connect the modules. So this is the LED cabinet. We run it with the receiving cards. Sometimes we just use one card for one cabinet. Sometimes if the resolution of one cabinet is really big, so we need to use two cards. All right, this is LED screen. This is LED screen. It consists of several cabinets arranged according to certain rules. Yes, this screen is made by cabinets, just like the PowerPoint shows. Well, you must say, yes, I've already know the LED screen, but how can you run picture on the LED screen? So this is the basic structure. First of all, we need a PC or laptop or just a media player, which can provide the video source. And second, we need to use the cables, HDMI, DVI, or DisplayPort, that for giving the video source. And what about the USB or Ethernet cable? That for controlling the sending card, that for send the command. Let's say the instructor, the PC and video cables and also the control cables and also the sending controller. The sending controller is the head of the system. We cannot do anything without the sending card. I mean the sending controller here. And for the sending controller, we can see here, there got 16 Ethernet outputs, and we just run the screen by the Ethernet cable, The LED screen wall, they got several cabinets, so we run them by the Ethernet cable and directly from those ports, All right, after that, I think we have to know another thing about the method. We got the pixel to pixel. You would say, what is a pixel to pixel? Yes, I think you might know that kind of situation. If your video source is big one, just a full HD or 1366 by 768, but your screen resolution is 700 by 500 by 500. So what is the result? Let's say this is the source resolution and this is the screen resolution. You will see the real screen only got a part of the source. You can see they just show a part because this is pixel to pixel. But how can we solve that, or how can we show the full image? We got the scale, screen scale. Let's say it's still the bigger source resolution. It's still the bigger source resolution. But we add one more device, the J6, the video processor. The video processor, it can just process the video or just switch the format and also switch the resolution. Let's say the source resolution is bigger than the screen resolution, but this video processor, it just switch the source resolution to the 700 by 500. Then we can show the full image on the screen. Well, so for the whole LED display system, it should be the control PC and the video processor and also the sending controller and the receiving cards. Yes, the LED screen wall. Let's see this. We need to use the control PC to give the video source to the video processor, and the video processor just switch the resolution or the video format to the sending controller. And the control PC just used to control the sending controller to give the configuration or give the screen connection. And the sending controller just to use the Ethernet cable connect to the LED wall. This is how we run the LED screen. All right, next, let's say the standard resolution. We got a full HD and 2K and 4K UHD. You can just note all the things here. You can note all the things here, or you can do the screenshot. You can do the screenshot for this picture, because this will be a little bit useful for you guys. Because every time we talk about the yeah, I got the screen. Yes, it's 4K. But the 4K still got the 4096 by 2160, and also the 3840 by 2160. So you got real different. So if you can just do the screenshot for this picture. All right, after the standard resolution, I will just show you the video bandwidth. And also this picture is really important. Let's say the VGA just supports 2560 by 1600, and the DVI-D support the same resolution as 60 Hertz. HDMI 1.B also the same. So please just make a note or just take the screenshot for this, the video bandwidth. And this will help your project in the future. All right. Let's say the next one, the loading capacity. I think most of us have the screen and do the project. And when we are talking about the project, we say we have the screen by just 3 meters by 2 meters. And if you are trying to ask NovaStar's engineer for help, you will say, yeah, I got a screen, it's P2 or P2.5, and the resolution is 3 meters by 2 meters. Actually, I have to say for the resolutions, for us or for the LED screen, we only talk about the pixel level. It's just like 700 pixels by 500 pixels. It's just like this. All right, let's say the loading capacity. I think most of you have used this device before. Yeah, this is the M-Control 300 and MSD 300. I think most of you have used that one before. Let's say the capacity is 1.3 million pixels. And each output port just got 0.65 million pixels. They have 2 ports, so the total capacity is 1.3 million pixels. Well, how to get the pixel resolution? This is a really good one, and it helps you to understand the project well. Let's say, for example, the cabinet dimension is 500 millimeter by 500 millimeter, and the pixel pitch is P3.91. Let's say the pixel resolution is pixel width by the pixel height, and the pixel width is cabinet width divided by the pixel pitch. That means 500 divided by 3.91. And the pixel height is the same one. The cabinet height divided by the pixel pitch. So let's say the pixel resolution is 500 divided by the 3.91 by 500 divided by 3.91. It equals 128 by 128. So this is the cabinet resolution. This is what we call pixel resolution for one cabinet. All right, after this one, I think you must want to know one thing. You may ask, yeah, how many cabinets can I use for one controller? Right? Yes, how many cabinets can be loaded by one output port? As I mentioned, the one port capacity is 0.65 million pixels. So what we have to do is only do the math. Let's see the example. The cabinet resolution is 192 by 192, and each output port is 0.65 million pixels. So the cabinet number equals the port capacity divided by the cabinet resolution. Let's do the math. We can see it's around 17. It's around 17. So this is the formula to This is a formula for calculating how many cabinets we need for one output port. And the next one, this part is a reason why one port capacity is 0.65 million pixels. I think it's better for you to make the notes or do the screenshot, because this is a little bit hard, just a little bit. All right, let's say, you know, sometimes we are using the cables to do the transmission. Maybe we will get some data loss, right? Data loss. And for our system, we will just lose around 6%, it's around 6%. And for one port, one output port, the bandwidth is 9 power of 10. So we just need to do the math for the things here. The capacity by frame rate by the R bit depths, G bit depths, B bit depths, that means RGB, the color depths. We always use 8-bit or 10-bit, right? So for the one port bandwidth, it equals the capacity by frame rate by R bit depths plus G bit depths and B bit depths. So we do the math here. It's around 0.65 million pixels. It's around 0.65 million pixels. Yep, let's say. What about we change that one? We use 10-bit or we use 12-bit. What about the capacity? Let's say, you can see the PowerPoint here. If you are using 10 or 12, it equals 16 because we just use that as two 8-bits. If you use 8 bits, then it means you just use one part. If you use more than 8-bit, that means you use them together. So that's the reason why the 10-bit or the 12-bit equals 16 bits. So this is a way to calculate. And you will say this is just a half. The reason here, the answer here is just a half the capacity. All right, let's say the capacity chart. See the capacity chart. Yeah, for the, this is based on average usage rate. For color depths, 16 Hertz, it's around 0.65 million pixels. If the color depth is 10 or 12 bits and the frame rate is 16, it's around 0.32 million pixels. You can just take a note or just have a screenshot because it's kind of important. And it will just help you. Let's say if you got this screen, it's around the full HD, but you have to use it as 60 Hertz or you have to use as 40 Hertz. Then you can do the math and you can just compare with the capacity per port. Then you can get the answer, what kind of controller you can use or what you can't use. All right, let's say next one. Before we only talked about the MSD300 and Control 300. That's the basic device from NovaStar, All right, let's say What about the 4 port output ports controller, 4 output ports controller? Yeah, I think most of you just saw that before. Yes, the 600, the VX4S, and 660, and also the Nova Pro HD, the 4 output port controller. Let's say one port got the capacity 0.65 million pixels, and the MSD300 got 2 ports. So it equals 1.3 million pixels. But what about this one? What about this one? If that equals 2.6 million pixels? The answer is no, it's not 2.6 million pixels. This is 2.3 million pixels. You may just wondering why it's 2.3 instead of 2.6. Because 0.65 million pixel by 4 times equals 2.6, right? Let's say the reason, because the single link DY only support 1024 by 768 or 1280 by 720, right? This is max resolution. Let's say the DVI, single link DVI max resolution, it equals 2304000. It's around 2.3 million pixels because the bandwidth of the single link DVI. So that's the reason why we got 4 ports, but it only supports 2.3 million pixels. All right. Let's say the capacity of other devices. Oh, sorry, I just forget the special resolution can be supported. Yeah, the 2048 by 1152. This is the first special resolution. The second one is 2560 by 960. 2560 by 960. Those two are the special resolution can be supported. All right, next one. Let's say the loading capacity of other devices, and also the max wave and max height. Let's say MSD 300 and Control 300, 1.3 million pixels, MSD 600, M Control 600, and M Control 660, 2.3 million pixels, M Control 660 Pro at 2.3 million pixels. Yes, this is total loading capacity and max wave and max height. I have to say one thing, that is for the max wave, we just need to use the total loading capacity divided by the max wave that equals the height on the max wave. And the same thing. If we got the max height, then we can just use the total loading capacity divided by this max height. And others all good. For the M Control 4K, this is a special one. For the common situation, it only supports 4092 by the wave and 4095 by the height. But you say this is 4K, you have to support 4096, right? Yes, but the graphic cards should support that. That means we cannot change anything from the M Control 4K. I mean, the maximum will be 4092. But if your graphic card supports 4096, and then you just use the graphic card connect the M Control 4K by the DP port or by the HDMI port, then you can get the real 4K resolution. That means your graphic cards should support first. Okay. Let's say the example of what I said. Yes, the height equals capacity divided by width. Let's say, for example, the M control 300, 1.3 million pixels divided by 3840 equals 338. And 1.3 million pixels divided by 2560, it equals 507. So this is a way to calculate the height under maximum width or the width under maximum height. All right. Does it mean as long as we know how many cabinets we can connect it, the project will be no problem? Yeah. Sometimes we do think about like this. We do think like this. Yes, I've already know how many cabinets I have to use, then nothing here. Well, let's say the real client cases. The screen resolution is 9020 by 1152, and each cabinet is 192 by 384. We got 10 columns and 3 rows, and the customer only have the M control 660 and system running at 60 Hertz. You will see, yeah, the Hertz, I mean the frequency here is really important. Is also really important in the system. All right, let's say this is a way we do the screen connection. We do the screen connection. You can just do the math. You can just do the math. We have for one port, we have 1, 2, 3, 4, 5, 6, 7, 8 total. We have 8 cabinets in total, and per cabinet is 192 by 384. So we can do the math, 192 by 384 by 8. That's the total resolution. You would say it's just less than the 0.65 million pixels, right? But what if we send it to the receiving code? It will just give you the sending card number 1, port number 1, exceed the load range. You will say it's only 8, but why it's exceed? All right, I will just explain later. Let's say this is a project. This is a project. Let's do the math. 192 by 384 by 9 times. It equals 663,552. And it's over 0.65 million pixels. It's over. That means it's overload, right? You will ask, I have 8 cabinets only for one port, but why you calculate as 9 cabinets? Let's say, yep. This is logic from NovaStar. Let's say the left side, the 192 by 384 by 9. Yes, it's over 0.65 million pixels. But for the right side, it's less than the 0.65 million pixels. But if we connect the cabinet the way at right side, the system will calculate automatically as the left side, as a square or rectangle, We have to know this. It will calculate automatically as rectangle or squares. No matter how many cabinets you really use, even you look at the right side, even if you are using seven cabinets, but the system will also calculate them as 9 cabinets as a whole square. or whole rectangle. So for the client, we just after the calculation, and we just do one thing. We change the screen connection method. Let's say the first port 1, 2, 3, 4, 5, 6, 7, 8. Yes, we use 8 cabinets, and for this time, it works. So let's see the difference. For this picture, it's only a line for port 1. Let's say port 1. Totally, we got 8 receiving cards, right? Because this is just like a square or the rectangle. But let's say what they did before. They make things like this way. The system will calculate them as a square or rectangle. So the system calculated them as 9 cabinets, as 9 cabinets. And for this one, it only calculates as 8 cabinets. This is really important. I think you can just note it or take a screenshot, because this will help your project and in the future. Let's say the port 1, port 2, port 3. Yes, those 3 ports has 8 cabinets, and for the last one, it has 6. So nothing overloaded. So that's the reason why we can send it. The information has been successfully saved. So this is the way how we make it. For the physical connection, it's like this, and also we do the connection from the software in the same way. Okay. For now, we talked about the basic information of our system, right? We've already know that one. So for now, we are going to learn how to do the configuration, because we've already know that one. See, port 1, port 2, port 3, port 4, but you will just ask, how can we do that? And what kind of software I have to use, and what kind of devices I have to use, and what kind of things I have to know. Yes, later I will just show you the Nova LCD basic configuration. All right, for this part, I will just introduce how can we do the screen configuration from the RCFGX files making, and also the screen connection making. And just some basic ways to use the software. Let's say system structure review. Yes, we talked about this before. We talked about this before, the basic structures. I think you still remember that. The PC gives the HDMI or DVI or DP signal to the sending controller, and the sending controller use the Ethernet ports to the LED wall. This is the structure. Please remember that. Yeah, this part should have one more USB cable or Ethernet cable to control that one. Okay. Let's say this is our software named Nova LCT Mars. Usually we call that Nova LCT. All right, let's say for the project, if you've already got a screen, I think the most important thing is just to check the firmware. But it depends, I have to say, but it depends. If you've already got a screen from the factory or your manufacturer and they make things all good to you, then things will be fine. But first of all, for some screen you don't know, or you first meet, for the new screen you've never met before and you don't know what is that. So the first thing is check firmware. Let's say this is our software named Nova LCT Mars. First of all, what we have to do is click user and choose advanced synchronous system user login. And the password is admin, ADMIN. Then you can just log in the software and you can do the things you want. All right, how to check this? This is this is after logging in. Now we can see the difference. For this part, it only have the brightness, but after logging in, we have the quick configuration and screen configuration. For the most of things, we are using screen configurations, but for now, we're going to talk about the check firmware first. So how can we check firmware? And it's really easy. You don't need to do anything else. You just need to enter admin again. Then the hidden page will just pop up. And then click refresh here. Then we can read all the things about the sending card, about the receiving card. All the firmware we can read here. All right, let's say, one more thing. How can we just update the firmware? First, we choose the browser and choose the correct file here and only click update, that's all. But sometimes we need to update all the receiving cards, but sometimes we just give the specific receiving card. That depends. All right, let's say, for NovaStar, we have lots of different firmware. Let's say, what is the difference between them? I mean, it's not about the features difference. I mean, just from the name difference. We can see the things. For standard firmware, we have we call that STD. Yeah, standard firmware, that 4.5.0.0. It just seems like that. You got two numbers and the last numbers will be 0. That is a standard firmware. Sorry. For the customized firmware, we always got different numbers. In the last two parts. Let's say the 4.3.1.19, and also they got the custom for some blah 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 SC. Yes, because why we have different firmware? Why we have customized the firmware? Because sometimes the standard firmware cannot support some decoding chips, driver chips, and also some special features. That's the reason why. Yes, if you find the firmware of your receiving card or sending controller are customized one, please do not randomly change it. That means if you find this is customized firmware, I think it's better to contact your manufacturer or contact our engineer to help you solve all the things. Because maybe this is customized for some special features So we need to clear things first, and then we can help. And please, if you see anything about the customized version, please do not randomly change it unless you know things, unless you know it well, or unless you deal with that before. All right, let's say after checking the firmware and after checking the firmware, what is the next? Then what we have to do is stand step to configure. Stand step to configure. So what about the steps? We have 4 steps. The first one is graphic card settings, and the second one is sending card settings, and the third one is receiving card settings, and the last one is screen connection. You will say, yeah, it's really hard or it's complicated. But I will just show you how can we make it. And let's say, first of all, graphic card settings. I think this is a little bit important. Yes, so click red mouse on your desktop and then click the display settings. We can just give the resolution here, and also they change the size of the text apps, and you just need to use the right commands. All right, this is about the graphic card settings. It's really easy, or you don't need to set this. It depends. Let's say if your screen is full HD, but your laptop resolution is 1366 by 768. So for this part, you need to change that resolution to full HD. I mean, change your PC resolution to full HD, because the LED screen you have is full HD resolution. All right. Let's say the sending card controller setting. This is the important part. Let's say, first of all, we have to click screen configuration. Yes, we're going to configure the screen and give more details to the controller. Let's say, I think most of you have seen that before. Yes, the sending card page. Let's say the current display mode, we have sending card, yes, the full HD, and graphic card output is full HD as well, and current video source is HDMI. I have to say one thing. That is really important for your sending card resolution equals the graphic card's output resolution. That means pixel to pixel. All right, let's say, how can we change the sending card resolution? The source configuration. We can choose the video source here, HDMI, DVI, or anything else. And also we can choose the resolution here, the full HD or other customized resolution, or some special resolution. And the refresh rate we can also change, and input source bit depths we can also change. That depends. First of all, we have to click site. If you think, yes, all things are good, HDMI here and full HD here and 660 refresh rate, and then click site, and then click refresh, and just read the current display mode. Make sure the sending card resolution equals graphic card's output resolution. And don't forget click save here. Yeah, the sending card resolution equals graphic card output resolution and video source resolution. Let's say receiving card settings. I think most of you, yes, was struggling on this, and also mine. Yes, me too. Let's say you got several parts: the module information, the cabinet information, and the performance settings. For today, because all the things is basic functions and a basic way to use the software. So I've just tried to introduce some fast way to make the RCFG. Yes, the fast way to make the RCFG. All right, let's say the module information. Let's say the module information. First of all, if you just open this tab, you will get all the things here. But remember one thing. If last time the screen is not the one you are using now, then all the parameters here you have to read. You have to read from the receiving card. Or it will just saved just before screen. Just all the parameters here is another screen. It's not the one you are using now. So when we are getting this tape, the first thing we have to do is read from receiving card to make sure we are reading the parameters of the current screen, We have to use the read from receiving card. All right, let's say the module information, we got the chips, we got the common chips or ICN or NBI, the different types. And also the size, we got, this is a module size, 128 by 64. Yes, you have to know that is pixels, And scanning type, 1/32, 1/16, 1/8, 1/4. I think you just saw that before or something. And the direction, horizontal or vertical. We got different direction. Sorry. And also here we got the data groups. And this is all the information for the module here. And do you remember at the beginning, we just talked about the module, the cabinet, and the screen. Let's say from this part, we have to make sure the module, and then we give the parameters of the cabinet. So we can just see that the size is 128 by 64, and for the cabinet information, you will see the weight is still 128, but the height is just 512. You will say yes, 512 divided by 6. Divided by 64, yes, divided by 64, it equals 8. So you can find for the height, we have 8 modules. So we can just think about it. We can imagine that for this cabinet, is just like a long one, a taller one, a tall screen. All right, this is about the cabinet information. We can read it here, but sometimes we have regular or irregular. Today we only talk about the regular one. And for the performance settings, you got data group exchange and more settings. You got many details here, and it's really hard to explain all the details here. If you have any questions, or if you were struggling for this performance settings, or you cannot make things all good, you can just take the questions on the chat zone, and then we will just gather them all, okay? Because for the receiving card settings, kind of important. It's kind of important. We have to know the things. We have to know the things. If you have any questions, please just type it out on the chat zone. All right. Let's say, yes, we are going to we are going to find some easy ways. What is the easy ways? That means we can just load, upload the RCFGX file. We can upload the RCFGX file. Let's say, how can we get the RCFGX file? The manufacturer, or from NovaStar Engineer, or by yourself, Those are the three ways of getting the RCFGX files. Actually, for the first thing, if you just buy the screen from the manufacturer or the screen factory, yes, you will get the RCFGX files. But if the screen runs several years and things all missed or something, you can just contact the manufacturer or contact our NovaStar engineer for the configuration, or for some more details we can help. All right. The last one is by yourself. I think it's still, it takes time to make the configuration. Yeah, it takes time. But for today's topic, we are not going to tell you the details about how you can make the RCFGX files by yourself. Yes, we only talk about the manufacturer. You can get the RCFGX from the manufacturer or from NovaStar engineer. And because this is a fundamental classes, so we're not going to talk about the way you can make your RCFGX files by yourself. All right, let's say, what about once you've got the correct RCFGX files from manufacturer or from NovaStar engineer? First of all, we can just click load from file. We can just click load from file, and then you just choose a file, and things are good here. Just click send it to receiving card and to all the receiving card. By the way, all the receiving card, that means send to all the things, to all the receiving cards you're connected now. But it should be one thing is really important. One thing is really, really important. That is, all the receiving cards should have the same resolution. Let's say the cabinet resolution is 128 by 512. So all the receiving cards should have the same resolution here. What if the resolution they are not same? Then the screen cannot show directly. Yeah, it cannot work properly. You will see some you just like some part missing, or some parts just like a copy in one cabinet. All right. Then what if we have different size of the cabinets? How can we do that? Let's say you got the specific receiving card. All right, and then click send to all the receiving card, and you can just check the effect on that screen. And the things all good. I mean, for now, if you send it to the receiving card, and for example, you have 12 cabinets. After sending that RCFGX files to those cabinets, then they will get 12 copies. 12 copies. I mean, the 12th cabinet shows the same image. That means it's okay, it's good, and the RCFGX files is correct. And don't forget click save here. Don't forget to click save here. Yep, I've just mentioned the read from receiving card because we don't know the screen you are using now. If it is the one you used before, I mean, the parameters here should be same as the screen you are using now. So we have to click read from the receiving card, and this is the way to read it back. Click it and give the things here. And also, there got one more usage. What can we do by read from receiving card? First of all, you just look at the screen. Yes, the screen works properly. The screen works properly, and you just need to read from the receiving card and give the numbers, the sending card number 1, the port number 1, and the receiving card number 1. That means the first cabinet, you can read the files back. And then you can just click that one to save to file. And then you can get the RCFGX file. And then you can get the RCFGX files. Yeah. And now let me show you. Yes, this is a correct way. You can see you got lots of copies, just the same image here, just the same image here, just the same image here. Without screen connection, each cabinet show the same image. So if your screen is working like this, that means the RCFGX files is correct. What you only have to do is do the screen connection. Do the screen connection. Let's say, how can we do the screen connection? First thing, yes, we have to make sure how many screens we have. But usually we have only one. Usually we only have one screen. And the number 2, for the columns, for the rows, let's say, what is the columns, what is rows? Yes. How many columns of the cabinets and how many rows of the cabinets? Right, for example, the columns 4 and the rows 2. This is a result. 1, 2, 3, 4 for the columns, and 1, 2, 2 for the rows. Yes, this is kind of important. What is next? We have to know one thing. We have to know which sending card we are using now. Yes, for example, here 1, 2, 3, 4, 5. That means we have 5 devices. That depends how many devices you have. This is how many devices you have. And let's say the Ethernet port number. As we know, yes, the M-Control 300 got 2 ports, and the 4K got 16 ports. I mean, we've already saw that. We've already saw that from the preview PowerPoint. We have the 4K backside and MSD or M-Control 300. We know that ports, yes. So for this part, we have to choose correct sending card number and choose correct Ethernet port number. What is the 4th step? The receiving card size here, If you remember that, you will just say, yes, the width is 1 to 8. The height is 1 to 8. But for here, we have 1 to 8 by 512. So for the receiving card size, we have to enter 1 to 8 by the of the width and the 512 of the height. Yes, and this let's say, yeah, for this part it's just an example, for the receiving card size, just an example. It should be same as the receiving card resolution. Yeah, the receiving card size is a receiving card resolution. I mean the cabinet resolution. Okay. Yes, let's say this. We got the quick connection. Let's say yes, it starts from the top right corner, and goes left and down goes right. Yeah, this is a direction. This is a direction. So we can do the things like we click this part and just move your mouse by clicking each cabinet to do this. Or we can do the quick connection. Let's say it starts from right top corner and down and to the right. Let's say the first one, the second one, the third one is the same thing, from right top corner and left and down and goes right. By the way, I have to say one thing. All the connection here, you can just regard you stand in front of the screen, okay? Just like you're watching TV, it's just the same feeling. You stand in front of the screen and look at the screen and do the screen connection. Yes, and for this part, this is a real, the physical connection for your cabinets, Also, after things all good, you will get the complete image. And don't forget to click Save to Hardware, and also don't forget to click Save here. All right, let's say we got one more features we called mapping. What is mapping? Mapping is really useful for you to make the screen configuration. I will just show you pictures. Let's say, yes, this is before, yeah, the screen. Let's say, since all good here, the RCFEX file works properly, but the screen is not good. Yes, that means we gave the wrong screen connection. But how can we get the correct way? Enable the mapping. Let me say the P means port. P01, P01. That means the port 1, the sharp 001, sharp 002. That means the sorry. That means the first receiving card, the second receiving card, the third receiving card, and so on. So that means port number 1 and the receiving card 1, 2, 3, 4, 5. So that's the way we make the screen connection. Yes, port number 1, port number 2, port number 3, port number 4. And we can just use this to make the screen configuration, Let's say there got 1, 2, 3, 4 columns and 1, 2, 3, 4 rows. So in this tape, we can give columns 4, we can give rows and 4, and also the sending card, let's say Yes, this is for one sending card. Let's say the port number 1, receiving card number 1. Let's go back. Yes, sending card number 1 and Ethernet port number 1, and click the left top side directly to right till the end, and change another port number 2 and make new start 1, 2, 3, 4 again, and make a new one, the third port, and 1, 2, 3, 4 again. That's the way we do the screen connection. Okay, after that, we will say all the things. I mean, the pictures will shows on the screen now. And do not forget, read it from hardware and save to file. And also the same way of the receiving card, you can load from file. You can load the file if you get the correct one. And also you may ask, send to hardware and save. And what about the save system? Yes, save system coefficient. This is for the whole configuration files, including receiving card RCFGX files and the screen connection. This for the both. Oh, sorry. This is for the both. And for the next part, we can just read the communication status. We can read the communication status. Let's say the port 1 receiving call 43215678. Yeah, you can just remember those numbers, and I will just show you the relationships between this page and the screen configuration page. Let's say it starts from this tape. It starts from top right top corner, right top corner, 1, 2, 3, 4, 5, 6, 7, 8. And for the receiving card here, status here, that is 43215678. That means all the screen connections and just to detect the communications, you can find one thing. It makes from the left to the right, and from the top to the bottom. And I think this will help you to locate where is wrong or where is error receiving card. Sorry, just hold on a second. All right. Hold on a second, my PowerPoint just crashed. All right, sorry, I'm back. Yes. All right, that's good. Let's move on. This is a way to check the communication status. All right, let's just do the review of today's topic. We just talk about the basic ways, the basic things about the LED modules, and about pixel to pixel, about LED modules, about LED cabinets, and about the LED screen. Yes. Yeah, the cabinets consist of several modules, and the LED screen consists of several cabinets. And what next? And the next is the basic structure. The basic structure. Yeah, we have to use PC, we have to use sending cards, and directly to the LED screen wall. And what next? We just talked the pixel to pixel and screen scale, the screen scale. How to make the different resolution. I mean, the video source resolution is different from your screen. So how can we make the full screen on the screen? We have to use the video processor. We have to precise the video resolution. And the whole system, the control PC, video processor, the sending card controller, and the LED wall. And we also learned the standard resolution Full HD, 2K, 4K UHD, like this. And also we talked about the video bandwidth. And let's say the loading capacity. We talked loading capacity. We know the why the one port capacity is 0.65 million pixels, and we know why the 600 only support 2.3 million pixels. And also we know the way to calculate the cabinet resolution by we only know the cabinet dimension and pixel pitch. And also we learned how many cabinets can be loaded by one output port. And also we've already know the reason why one port supports 0.65 million pixels, right? This is today's topic. And later, and we will just answer all the questions from the chat Zoom. And for now, if you have any other questions, please just feel free and enter that to the chat Zoom, and we will gather them all. And give you the final answer. Sorry, we had to gather all the questions, and we will just mute for a few minutes, and we'll back soon.